In this example, we're going to solve the system by substitution. So recall step one is to look at your two equations and see where you have a variable term with a coefficient of 1 or -1. So we see that only equation number 2 has a variable term that has a coefficient of 1, and that's the y value. So we're going to use that equation and solve for y, which means we want to get y by itself, everybody else on the other side, using the rules of equation. So what will be my first step to getting y by itself? If you said subtract 5x from each side, that is correct. And now that we've solved for y, we took that from equation number 2. Now we're going to plug that into equation number 1, the one we didn't use. We're going to plug in -5x minus 2, and we're going to plug it in y's place. So substitution method again is about first solving an equation for x or y. Take that equation and plug it into the other equation. So let's go ahead and do that. Once you plug it into the other equation, your next step then is to simply just solve the equation. So to do that, we need to use the distributive property, -4 times -5x, and then -4 times -2. Bring everything else down. Next, we want to combine like terms while they're on the same side. 3x plus 20x equals 23x. Next, what do? Yes, we're going to subtract 8 from each side. Divide by 23, and x equals -1. So now that we have our x value of our solution, how do we find our y? Well, we can plug it into either equation. It is always the quickest method, plugging it into your third equation, the last one that you created, because it is already solved for that variable y. All you have to do is plug in the value for x on the other side and then solve. So plug it in x's place, and then you'll already solve for y. So let's go ahead and do that on the next page. Okay, let's go ahead and plug in -1 for x so that we can solve for y. So we have here -5 times -1, which is +5. 5 take away 2 equals 3. So your y value is 3. So therefore, my ordered pair solution is -1, 3. And remember, step 5 is optional. You always have that option of checking your solution if you're not sure about your answer. We have the ordered pair of -1, 3, and we want to determine whether that is a solution to the system. And all you have to do is, in x's place, replace it with a -1 and replace y with a 3. If when you plug it into both of the equations, if it leaves you with a true statement, meaning both sides are the same, then that is your proof that it is indeed a solution. And so plugging in that ordered pair into the first equation, it does check out. And also plugging it into the second equation, it checks out as well. So therefore, yes, -1, 3 is the solution to the systems of equations.